Alright, let's move on to our first major concept in coordinate geometry, a concept that's all about steepness and direction, the gradient of a straight line. Think about climbing a hill or tackling a challenging set of stairs, like those famous, super steep ones you find at Bukit Timah Nature Reserve. Perhaps you've heard of the Devil's Stairs or the Summit Trail there. Some climbs are easy, almost flat, while others leave you breathless. The gradient is simply how we mathematically measure that steepness or slope of a line. In simple terms, the gradient tells us how much a line goes up. That's the rise. For every unit it goes across, that's the run. Rise refers to the vertical change, how much you go up or down. Run refers to the horizontal change, how much you go across. So let's put that into perspective. A gentle slope means you have a small rise over a relatively long run. Imagine a smooth, gentle ramp designed for wheelchairs. It gradually goes up. A steep slope means a large rise over a short run. This is exactly like those challenging, steep staircases at Bukit Timah, where you gain a lot of height very quickly. And what about perfectly flat ground? Like walking along the expansive, flat pathways at East Coast Park. That's what we call a zero gradient because there's absolutely no rise at all. You're moving horizontally, but your height isn't changing. Now, why does understanding gradient matter beyond just hiking or looking at scenery? It's a fundamental concept with huge real-world applications. It's used when designing MRT tracks to ensure a smooth and safe ride for passengers. It's crucial for analyzing financial trends, which we'll look at next. It tells us if investments are going up or down. Engineers use it to design safe roads and paths, ensuring they're not too steep for vehicles or pedestrians. And it's vital for creating accessible ramps for people with disabilities, ensuring they meet safety standards. So the gradient isn't just a number. It's a powerful tool that helps us understand the world's inclines and declines. Let's dive into another real-world application of gradients, something that probably gets everyone's attention. Your money matters. Gradients are absolutely everywhere, especially in the world of finance. Imagine for a moment that you've decided to be a smart saver and investor. Maybe you've put some money into stocks through your POSB or DBS account. When you look at your investment chart, which shows how your money has performed over time, the gradient of that chart tells you a clear and immediate story. Is your money growing, or is it shrinking? If you see a section of the line with a positive gradient, that means the line on your investment chart is heading upwards. This is fantastic news. It indicates that the value of your investment is increasing over time. And here's the cool part. The steeper that positive gradient, the faster your money is growing. Imagine seeing your savings climb rapidly. That's a steep positive gradient at work. But what if you see a section with a negative gradient? That means the line on your investment chart is going downwards. Oh, this tells you that the value of your investment is currently decreasing. So simply by understanding the concept of a gradient, whether it's positive or negative, and how steep it is, you can quickly and intuitively interpret trends in data. This isn't just limited to finance, it applies to population growth charts, climate change data, scientific experiments, and so much more. Gradients provide a powerful visual shortcut to understanding complex information instantly. It's a skill that will definitely serve you well in the future. Now that we understand what gradient is and why it's important, let's get down to the actual mathematics, the gradient formula. This is how we put a precise number to that steepness. The fundamental idea is simple. The gradient, which we often represent with the letter m, is defined as the rise divided by the run. It's literally how much vertical change there is for every unit of horizontal change. In terms of coordinates, if you have any two distinct points on a straight line, let's call them point A, x1, y1, and point B, x2, y2, we can calculate the rise and run using their coordinates. The rise is the vertical change, which we find by subtracting the y coordinates, y2 minus y1. This tells you precisely how many units the line has gone up or down vertically from point A to point B. The run is the horizontal change, which we find by subtracting the x coordinates, x2 minus x1. This tells you how many units the line has gone across horizontally from point A to point B. So by putting these together, our official gradient formula becomes m equals to y2 minus y1 all over x2 minus x1. This formula is incredibly powerful and versatile because it works for any straight line on the Cartesian plane. As long as you have the coordinates of any 2 points on that line, You can find its gradient and instantly understand its steepness and direction. It's a foundational piece of coordinate geometry that you'll use over and over again. Alright, enough theory. Let's put this gradient formula into action with a practical and relatable example. Imagine a drone soaring through the Singapore sky, flying in a perfectly straight line from one location to another. Let's say it starts at point A and flies to point B. We want to calculate the gradient of its flight path. How steeply it's ascending or descending. Here's how we calculate the gradient. Step by step. Step 1. Identify your points. It's super important to clearly label your coordinates. Our starting point, point A, is at 3, 3, so we'll assign x1 as 3 and y1 as 3. Our ending point, point B, is at 10, 7. This means x2 is 10 and y2 is 7. Step 2. Apply the gradient formula. Remember, our formula is m equals to y2 minus y1, all over x2 minus x1, or, if you prefer, rise over run. Step 3. Substitute the values. Now we plug in the numbers we identified. For the rise, it's 7 minus 3. For the run, it's 10 minus 3. So our equation becomes m equals to 7 minus 3 all over 10 minus 3. Step 4. Calculate the result. Let's do the simple arithmetic. 7 minus 3 gives us 4. 10 minus 3 gives us 7. So the gradient m is 4 over 7. If you convert that to a decimal, it's approximately 0.571. What does this result tell us? It means that for every 7 units the drone travels horizontally, it rises 4 units vertically. This positive gradient tells us the drone is ascending. Pretty straightforward once you break it down, right? You've just calculated a real-world flight path's steepness using coordinate geometry. Now, let's explore the two most common types of gradients, and they're pretty intuitive. Positive and negative gradients. These tell us the direction a line is sloping. First up, a positive gradient. This is when the value of m is greater than 0. Visually, if you look at a graph, a line with a positive gradient will always slope upwards as you move from left to right. What's happening mathematically? As you move forward horizontally, your vertical position, your elevation, is increasing. Think of it like this: your x values are getting larger, and your y values are also getting larger alongside them. A great real-life example is if you're walking up Bukit Timah Hill. As you take steps forward, you are definitely gaining elevation. The steeper the path, the larger that positive gradient is. On the other hand, we have a negative gradient. This is when the value of m is less than 0. Visually, a line with a negative gradient will slope downwards as you move from left to right. Mathematically, as you move forward horizontally, your vertical position, your elevation, is actually decreasing. This means as your x value increases, your y value decreases. A fun real-life example would be if you're speeding down a thrilling water slide at Wild Wild Wet. As you move forward along the slide, your height rapidly decreases. The faster you go down, the steeper, or more negative, the gradient of that slide's path. So remember, uphill slopes mean a positive gradient, and downhill slopes mean a negative gradient. It's all about understanding the direction of the change. Beyond positive and negative gradients, we have two very important and special cases that are crucial to understand. What happens when a line is perfectly horizontal or perfectly vertical? First, let's look at zero gradient, which is when the value of m equals to 0. This occurs with any perfectly horizontal line, because a horizontal line means there is absolutely no vertical change. No rise. The rise value in our formula is 0. Think about taking a leisurely stroll on the perfectly flat ground at East Coast Park. You're definitely moving forward. You have a run of, say, 300 meters, but your height isn't changing at all. So if you apply the formula, 0 over 300 still equals 0. A zero gradient signifies a completely flat surface. Next, we have the undefined gradient. This is a bit trickier but equally logical. This occurs with any perfectly vertical line. In this scenario, your run is 0 because you're moving straight up or down without any horizontal movement. Imagine, if you could, trying to climb straight up the side of a jib block. You're gaining a lot of rise, maybe 100 meters, but your horizontal movement, your run is 0. Mathematically, you cannot divide by 0. So if you try to put 100 over 0 into your calculator, it will give you an error or undefined. This means the gradient of a vertical line is undefined. It's infinitely steep. These special cases are just as vital to grasp as positive and negative gradients. as they describe very distinct and common orientations of lines on the coordinate plane. Alright, it's time to put your thinking caps on for our first gradient quiz. We've covered a lot about what gradient is, how to calculate it, and its different types. Now let's test your understanding with a few questions. We'll start with an easier one and gradually move to more challenging problems. Take a look at the easy question first. A line passes through 2 points, P with coordinates 1, 2 and Q with coordinates 5, 10. What is the gradient of the line segment P? Think about the formula for gradient that we just discussed. You can pause the video here to think about it. Next up, the medium question. A certain line has a gradient of 3. We know this line passes through 2 points, 2, 1 and 4k. Your task is to find the value of k. This requires a bit of algebra, but you've got this. You can pause the video here to think about it. And for our hard challenge, which combines a few concepts, imagine the north-south MRT line runs parallel to a line described by the equation y equals to negative 3x plus 5. Now, the east-west MRT line is perpendicular to the north-south line. Based on this information, what is the gradient of the east-west line? You can pause the video here to think about it. Don't worry if you don't get them all right immediately. The goal is to think through the steps. We'll go over the answers on the very next slide. Alright, it's time to reveal the answers and see how well you did on our gradient quiz. Let's go through them together. For the easy question, where the line passed through P1, 2 and Q5, 10, we used the gradient formula, y2 minus y1 over x2 minus x1. So that's 10 minus 2 all over 5 minus 1. This simplifies to 8 over 4, which gives us 2. So the correct answer is B2. If you got that, excellent start. Moving on to the medium question, where the line had a gradient of 3 and passed through 2, 1 and 4k. We know that the gradient m is 3, so we set k minus 1. All over 4 minus 2 equal to 3. This means k minus 1. All over 2 equals to 3. To solve for k, we multiplied both sides by 2, which gives us k minus 1 equals to 6. Then, we simply add 1 to both sides, and we find that k equals to 7. The correct answer is C7. Great job if you navigated that algebra. And for the hard question about our MRT lines, we're told the north-south line is parallel to y equals to negative 3x plus 5. Remember, parallel lines have the same gradient, so the gradient of the north-south line is negative 3. Next, the east-west line is perpendicular to the north-south line. For perpendicular lines, the product of their gradients is always negative 1. So if m1 is negative 3, then negative 3 multiplied by m2 equals to negative 1. Dividing negative 1 by negative 3, we get 1 over 3. Therefore, the correct answer is D1 over 3. This one required a good understanding of both parallel and perpendicular relationships. Give yourselves a huge pat on the back for every correct answer, and even for trying your best on the challenging ones. You're building a strong foundation.